today's experiment will talk about, and we'll do the experiment, talk about the Le Chatelier principle and the chemical equilibrium. So if somebody will ask you, what is chemical equilibrium? Or in the quiz, what is chemical equilibrium? It turns out chemical equilibrium is a chemical reaction by which the forward reaction from the product, from the reactant to product equal the rate. We are talking, when I say chemical equilibrium, I talk about the rate of the reaction. The rate of the forward reaction from reactant to the product will equal the rate of the reverse reaction from product to reactant. If the rates are equal, then we talk about chemical equilibrium. So let me show you here. We'll share the lab procedure. But before we go to the lab procedure, if I look at the whole thing here, let me just give you just a hint about this. So if I have here, if I have the A and B are reacting together, so I have A plus B are reacting to give you C plus D. So this is, we call this is the product. And this we call what? The reactants. Okay, now, as soon as this is the rate here, this way, forward. Correct? So as soon as those products are produced, they can decompose and producing back. That's called reverse. Producing back the reactants, and therefore we have an error that's, now this reaction goes back, backwards, reverse. So we call, if the rate of forward reaction, well, it did not want to take it, but we'll say here it is, A plus B, C plus D. Correct, guys? We said this forward rate of reaction this way, and the other way is reverse rate of reaction. If they are equal, here, then we speak about chemical equilibrium. Okay, guys, so if somebody will ask you, what is chemical equilibrium? A chemical equilibrium about the rates, not about the balancing number of atoms out or balancing number in the reactants equal number of the products. No, it's already balanced. The chemical equation has to be balanced to begin with, but we are talking about the rate of forward reaction producing the products equal the reverse rate of the reaction producing the reactants back. So at the end of each chemical equilibrium, we are talking about both reactants and products are present at the same time. That's the opposite. If you have a complete chemical reaction, you have only products at the end of the reaction. But here at the end of the reaction, you have both. You have reactants as well as products. So that's the difference here. So, and let me just take this one out. Maybe you have to more space. So here it is. What we said at the end of the reaction, if you have a chemical equilibrium, both reactants and products are present. So at the end of reaction, both products and reactants are present, and reactants are present. This is very important stuff we have to we have to know. So both of those are present. But if you don't have a chemical equilibrium, correct, then you have only products. Are you following me here? That's a complete reaction. So a chemical equilibrium is not a complete chemical reaction. Is not a complete. So the conclusion here is this is a chemical equilibrium. Is not complete reaction, because you'll find complete reaction, you'll have only what? You'll have only products present. But if you have both present, that you speak about chemical equilibrium. Now, let's go and look at the experiments. We have 5 experiments today, and they are straightforward. There's nothing really difficult about them. You can do them. We should be within 1 hour done. If you are doing this correct. If you are doing it, it's assuming that we are doing everything correct. So let me take this one here out, and let's look at the first reaction here. This is the first reaction. Okay, so you can look at the whole steps. What do you have to do in the first part of the procedure? You'll have a small tiny beaker here. Maybe I have to draw the whole thing here. You can see it. Small tiny beaker. In this beaker, you'll add, as it says, 20 mL of distilled H2O. So you have to this 20 mL H2O. Okay, distilled H2O. And then you'll add to this one here 20 drops. We said 20 drops is 1 ml, correct? 20 drops is about 1 ml of the yellow iron 3 nitrate, iron 3, which is this one here. And then you'll add potassium thiocyanate, 20 drops. You will stir. This is your stirrer here. Stir very well. So you have a yellow solution. The other one is colorless. When you mix them out, you get a deep red color. That's what you will obtain. When you mix 20 drops. This one is 20 drops as well. So 20 drops. Each of those reactants you take 20 drops, which is around 1 ml. Mix them, stir them very well, mix them very well, and then you will get that dark red color of a compound called iron thiocyanate, iron 3 thiocyanate. Now, this is red. Solution here is red. Now you will prepare yourself with 4 test tubes, medium size. You can label them so you can with your pencil or so. So this is 1, this is 2, this is 3, this is 4. Okay, you will take out of this is, remember how many? 20 plus 1 ml from here, 1 ml, 1 ml. So total here, how much? 22, correct? 22 ml. Total of this, 22 ml. Everybody agrees? 22, because you added 1 ml of the yellow solution of iron 3 nitrate. You added another 1 ml, about 1 ml. I mean, 20 drops is very rough, very crude estimation for 1 ml thiocyanate, and then you get the red. So now you take out of this 22 mixture here, you'll add to each of those from the mixture here. You switch your color so you can follow me. So you'll add to each, oops, you'll add to this, you'll add to this 3 mLs, 3 mLs, 3 mLs, 3 mLs. So 3 mLs in each test tube, in each test it does not want to write very well, so trying my best to. Okay, so 3 mLs in each. Okay, so from this solution, correct? You mix 1 from the yellow, iron 3 nitrate, 1 from the thiocyanate, 20 drops, 20 drops, and you get the red solution, stir it, then you take each from this solution 3 mLs to fill 4 test tubes. Okay, now you can, I can tell you all the procedure, but I'm interested in the chemical equilibrium. Okay, so now give it time, about 1 minute to go to the equilibrium. Of course, when you take it there, give it 1 minute or so. Then you will add to all of them. Here, number 1 will be your reference. So what you will do here in number 1, you will add to it just distilled H2O. You'll add to it what? Distilled H2O. So you have 3 mLs of the mixture here for each one. The first one, you will add 20 drops of H2O. So the reference here, you'll add H2O, about 1 ml, 20 drops. The second one, you will add to it iron, the yellow stuff, iron nitrate, iron 3 nitrate. Again, that's about 20 drops. The third one, you'll add thiocyanate, thiocyanate, 20 drops. And the fourth one, you'll add your potassium nitrate. So, add the reference H2O, you added iron nitrate the second, the third potassium cyanate, and the fourth one is nitrate. Okay, guys? Now the question is, what is happening when you add all these additions? Right? So, everybody has this. You can, a recording will be there and then will be available to you, so you can Yeah, so I'm recording it. So you can get this one in the recording, and then you can play the recording again and again and again. So I'm taking this one here. I just want to show you what will happen in all those 4 test tubes. Okay, so let's do it here. If I do it this way, then all the other will come, will follow the same procedure. So it does not want to go down. So here it is. What will happen if when I added H2O to this mixture, the red mixture? So I visualize the whole thing as I'll take the thicker bend and take red. So the chemical equilibrium is visualized as a balance with 2 arms. This is a balance with what? 2 arms. Here is the 0 reading, 0. It is 0 reading. So 0 reading means the both arms are what? Are balanced, correct? Then we have chemical equilibrium. We have equilibrium, means that both of them are balanced. So now, if, remember, I put the whole thing here, I'll switch to another, sorry. I'll switch to the pen that's a different color. So guys, I will visualize the whole thing here. This is the yellow. You might be not able to see it, but this is iron. That's the reactant side, okay? And the other one maybe will take the blue one, correct? So this is thiocyanate. Those are, as I said, reactant side. This is reactant. And those are products. Okay, guys. So here we have the red. We have the red. We have the red. Correct. Of the product, the red, and we have this colorless of potassium nitrate, correct? So now, this is at the arm is at now reads the arm, the balance read 0, means both arms are what? As I said, this is reactants. This is products, correct? And those are the reaction. What will happen if I added H2O? What will happen if I added what? H2O. So here it is. Ask yourself, what will happen if I add another H2O? Well, it turns out to be, if I added H2O here, H2O will add itself in both sides, correct? So H2O will have no effect. So the first test tube will tell you that H2O addition to both sides has no effect, correct? Now, in the second test tube, you added extra yellow stuff, the iron 3 nitrate. So now it's another story. I added so I added here somewhere, that's extra, correct? Yellow stuff. What will happen to this arm? Somebody will tell me. Will it be lighter or heavier? You added the same material. It's not added like the H2O. H2O is added itself in both sides, correct? Because it does not react. but it's not part, it's a solvent. But now you added the extra more yellow, correct, on this arm. So this arm will be going what? Oops, sorry. This arm will go what? So this arm will be heavier, correct? And this one will be lighter, correct? So the whole thing is tilted which way? This way. Like the whole thing will be looking, if you have a small tiny picture out of it, the whole thing will be looking, this is down, this is up. Now, you have added stress, you have added a condition that's causing this equilibrium balance, two arms of the balance to be tilted, to be shifted to the bottom of the left side is heavier, correct? So in order to get those balance, what will happen? Where will be the shift? What should I do? Somebody will tell me? What should I do? Remember, this is overweight here. So some of the weight had to be given to what? To the other side, correct? So therefore, we say the shift of the chemical reaction is to the right, to the right side, to the product side. Okay, so shift. Conclusion here is when you add the yellow stuff to the test tube number 2, which is iron nitrate, to this mixture. So the shift will be which way? This shift will be to the right. Now the question is what evidence you can see. Evidence, if it's already red, it will be more reddish, correct? So more red color. That's we call it evidence. Okay, guys? Make sense? Make sense? Everybody has this? That will be in the recording. So don't worry, you can stop the recording and then take picture of it. But let me go and look what will happen if I will add now, I will add other stuff. I will add the second one, okay? So, I mean, I can take this one, but I like to take the whole thing out. Now, let's look at this. I'm adding the second part, okay? So I'm adding this one here. So I add, this is correct, and those are 2 here, correct? Here it is. Does not want to take it, so every time. I'm adding this. If I call this one number 1, this is number 2. I added, this is number 1, 2, 3, and 4. 3 and 4. So now, this is at equilibrium, correct? But I added more of what? Of 2. So I added more of 2. Another 2 here. So what will happen? Which arm will be heavier than the other one? Which one arm of the bonds will be heavier? Which one will be lighter? This one will be heavier? Yes, so this one will be heavier because you added 1, 2, 2. More of 2, correct? Which is this one here, this number 2. My goodness, this looks like today is, I'm not superstitious. I was telling this today is Monday, but today is not Monday, correct? But the WebEx is acting like today is Monday. So here it is. 1, 2, 3, 4. So we have, my goodness, does not want to take it. So it's insisting it is Monday. No, it is Tuesday, Mr. Webex. So let me see. We'll take it again. Okay, so this is 1, 2, 3, 4. 1, 2, 3, 4. So 3 and 4 are the products. 1 and 2 are reactive. Okay. So now I'm adding another 2 here. Another 2. So we said this one will go down. This one will go up. So in order to reestablish that the tilting of the balance, I did not tilt it. It will be looking like this picture when you add. Looking like this again. This one down. This one's up. So I want to reestablish the 2 arms to be changed. What should I have? Some of the weight here has to what? Shift here. So conclusion is shift where? Shift to the right. My goodness. Shift to the right. So shift will be which way? So it was like this. Here we have 3 and 4. 1, 2, 2. 1, 2, 3, 4. Shift to the right. What evidence? More what? Red color, correct. This is for test tube number what? Number 2. Now, test number 2, correct? No, that's test tube. No, that's 3. That's 3. Because test tube 1 is H2O, and then this test tube iron nitrate 2. That's test tube number 3. So this is test tube 3. Okay. Now we'll add number 4. What will happen if I add number 4? Where the picture will look like? I will draw it for you, but can you tell me which the answer will be? So let's look at, I hope it will allow us here. Test tube 4. I added number 4. So the test tube 4 will be what? I added number 4. So the heavier part will be where? To the right, correct? So it will be looking like this. Correct? So this is lighter because it has 1 and 2. This one has 3, 4, 4. It has 3 items, here 2 items. So the reactant side is 1 and 2. 1 and 2 here, 3 and 4. So where will be the shift then in this case? Test tube 4 will be where? To the right or to the left? This is heavier, correct? Shift will be where? To the left, correct. So shift L to the left. What evidence you will see? Less red color, correct? If you go to the right, that's more red color because of this. It's already red. If you go to the left, there will be less. So evidence. Less red color. Make sense? That's the first part. That's what we call it. This is called Le Chatelier principle. Le Chatelier principle, as you have seen by the experiment, if you put stress from outside on a chemical equilibrium, the chemical equilibrium will try to readjust itself by going to the side with the least stress every time. Look, this arm was stressed out went down. So in order to reestablish, it has to take some of the weight and bring it back to the right, correct? This here, right side was stressed out, correct? Some of the weight has to go to the other side. So that's what said Le Chatelier principle says whenever you put an external stress or condition on a chemical equilibrium that will, will disturb this equilibrium, then the chemical equilibrium will try its best to readjust itself by going to the side with the least stress, correct? The least weight here in this as an example of the balance. Make sense, guys? Now you are professional. So let's look at the second one. You are professional. We'll not draw any balances anymore. Now we are professional. I'll tell you where's the shift. You will tell me like this. The shift will go left or right, correct? Let's see. Second experiment. Let's see the second experiment. Okay, let's go on the second one. So the second one is we have an indicator. So okay, here it is. So we have an indicator. As you can see, this is bromothymol here. Just write it here. This is an indicator. We talked about the indicator before. What are those indicators? Indicators are what? Organic dyes. Whenever you change their medium, the acidity or basicity of the medium, they change their color. Are you following me here? This is the same thing with if you dye your hair, the organic dyes are really indicators, because I can take any dye my hair a color, then put an acid like small tiny vinegar on it, acid, or a base, any base on it, you'll see the color of this dye will change. So you can change your dye without buying any. Just take one color, and then this color can switch color according whatever the medium is, acid or base, acidic medium. So this is the form of an acid, which is in bromothymol. This is yellow. This is acid. This one here, this is blue, dark blue, right? So it's dark blue, or deep blue, whatever you name it, deep blue or dark blue. So, and this is a base form. So now you will have test tubes, and you test all this stuff. You have two test tubes, 1 and 2, correct? It said obtain 2 clean small test tubes, and then you will add to all of them here 20 drops H2O, just to dilute the color a little bit. It's very dark, deep, so deep color. So this is 20 drops H2O to both sides. And then when you add to this, you will add 20 drops of your indicator in each of those. So not 20 drops. I would say it's 1 to 2 drops. I would say add 3 drops here. So put 3 drops, so you can see the change. You can see that. So you will add to this 3 drops each. So both of them at the beginning will look what? Blue. So the indicator is blue. So both of them will be looking blue. This is number 1. This is number 2 test tubes. So both of them you added 20 mL of H2O and 3 drops of the indicator bromothymol blue. Both sides will be, both test tubes will be looking blue. Now we'll add sodium hydroxide as a base, and you'll add HCl as an acid. Here you can follow whatever it says, but it's really, it does not really matter if the, you know. So you'll add 3 drops each of sodium hydroxide, or indicator, you'll add the same thing here, not 1 drop of the indicator, you'll add maybe more, 3 drops maybe. I wanted to see the difference here. Okay, so we added 3 drops of the indicator. Then you'll add 3 drops of sodium hydroxide, test tube 1. So test tube 1, you'll add sodium hydroxide, which is about 3 drops, and you'll stir. Test tube 2, and you have to record what? You have to record the color. Okay? Sodium hydroxide. When you add sodium hydroxide, what will happen? So then the second one, we can add HCl to it. Okay? About 3 drops HCl. Okay? So this one, what will be the color of it? What's the color will be here? What's the color? Somebody will tell me. You started with the blue color of the indicator, dark or deep blue color. So you add the sodium hydroxide to the first. Sodium hydroxide is a base. The second one, you added HCl. So what you can expect here? Well, it turns out, can I take this one here? I'll show you what will happen. When you add sodium hydroxide here will take from this reaction. Here's your balance here. Will scavenge, it has OH here. Sodium hydroxide, it has OH. That's the base here. That's the base. Will combine itself, will remove the hydrogen, the proton, H plus. So this arm will be what? Will be less, because you have a scavenger, a base scavenging the proton. So this arm of the balance will be less. This arm will be heavier, correct? Because you added a base. Right? So the shift will be where? Shift will be which way? This is lighter. Wherever is lighter, the shift will be to it, towards the lighter part. So the shift will be this way, to the right. When you add sodium hydroxide, shift to the right. Now, what evidence you will see? Blue, correct? It's set to the right. That's a blue color. To the right, that's to the right. That's a blue color. So that's the right side here. So right, and then evidence here, evidence, more blue color. Correct? Now, if you added HCl, what will happen? HCl, if you add HCl to this, HCl will provide you with H plus. The OH will provide you OH minus, correct? The H plus, HCl will add you H plus. The H plus add itself to the H plus. So this arm now will be what? When you add this, the arm of the balance is tilted this way, because this one here, oops, sorry. I'll just go ahead there. When you added HCl, the HCl will provide us with the H plus, and the proton is already in the left side to begin with, correct? So therefore, this arm will be looking like this. Why? Because you have more H plus here. You added HCl, so the H will add itself to the right side, and the shift has to be where? To the left. So here it is, to the left. That's the shift, correct? Evidence, less yellow, less what they call it. It will go to the left, means you will see yellow color, yellowish color. So weak yellowish color. So or you can see that the blue color is being what fainted. So the blue color will disappear slowly because you have this acidic form. Okay, guys. Now, the one that has HCl, can I take this one here out? Can I take this one here out? Okay, I'm taking this one out, and look. The first one here, I added sodium hydroxide. The first one, I added sodium hydroxide here, guys. Here it is. Just do one. I add the sodium hydroxide, correct? That's this one, number one. And when I add the sodium hydroxide, the shift was shift to the right, evidence, more blue color, more blue. When I added here, of course, I add the indicator here, of course, the indicator and H2O, indicator plus H2O inside. Here's the same thing, indicator plus H2O. So I added HCl. So the shift, we said, when you added HCl, the protons here at the left, the HCl provide more proton, so the shift will be to so this arm will be more stressed out. Shift will be to the left. Evidence, less blue color. If you add enough, you might get what? Yellowish color. If you add extra of the acid, extra HCl, you will see more yellowish. The blue color will fade out and get yellow. Okay, guys, that's the second one. Second one. Okay, so that's the shift. So let's take number 3. Well, here's number 3 is the same thing, but this time I'm not repeating myself. This time is, yes, instead of using indicator, you are using litmus paper. Litmus paper is a piece of paper that has soaked into an indicator, into organic dye. So you can make your universal indicator from red cabbage. Red cabbage is a very nice indicator. So you don't have to have litmus paper at home. You can just boil cut it in small pieces and boil it for maybe 30 minutes, let it cool, and then take all the leaves out, take the extract, cool it down, and then here we are. Take coffee paper, take coffee paper, let it soak in this extract, then let it dry in the sun. Here we are. You have a litmus paper, universal even. The pH from acidic all the way to high base, from 0 to 14. You can do this one here, and this an extra credit will come, I think, this coming Tuesday. I think Tuesday at 11 o'clock, but you will be not lucky. You will be working in the lab, but there is um, extra credit today. I was suggesting it to, I was talking to other professor, Professor Mark. He will show the other students. So this is what's happened in this litmus paper. The same thing with the indicator. So you have in your drawer, you have 2 types of litmus paper. You have, let me just take this one here. You have a red. This is red. litmus paper, and you have blue. Litmus paper. So what will happen here? You can take test tube, two test tubes here, as they say, okay, and you will add to them 20 drops of H2O just for dilution we are using. So you will add to the test tube one. You will add. You have two test tubes here, 1 and 2. So you will add to one sodium hydroxide, not that much, just a couple drops, 2 drops, 3 drops will be enough. And to this HCl, around maybe 2 to 3 drops HCl. And here, 2 to 3 drops. That's test tube number 2. Number 2 is this. Number 1 is this sodium hydroxide. So now what you will do here, you will test the red litmus in test tube 1. This is 1. This is 2. Well, since sodium hydroxide is a base, the red litmus paper will turn what? Blue, correct? And then you test it in number 2. It's already acidic for acid. The red for the acid, the blue for the base. So it will be no change. For test tube, when you take the red inside test tube 2, it has HCl. There will be no change, correct? Now take the blue one here and put it in the first one. The blue with the base, there will be no change. It will remain blue. Take the blue one, put it in the HCl. The blue will turn what? Right. That's acidic. Okay, that's basic. I mean, the blue one in the number 2 HCl, it will turn blue, correct? Everybody's following? So in order to test as acid or base, I took litmus paper. The red one, put in sodium hydroxide. Okay, will turn sodium hydroxide. The red one will turn blue. So this one here will turn blue. The red litmus will turn blue. Put it in the number 2, it has HCl, no change. Take the blue one, put it in the sodium hydroxide, no change. Take it in the HCl, it will turn blue, correct? That's what it says. So you can do it, test it, and look at the shift. The same thing we did with the indicator. Litmus paper is nothing less than just an organic dye soaked into the filter, thick filter, like a coffee filter. And you can do your own litmus paper at home from red cabbage. So let's go for the 4th one. And I think that will be the last one. The last one is a little bit more demanding, but it's not really difficult. Here it is. What will happen here, you need 2 test tubes. Okay, 2 test tubes. Here it is. We have to know whether the reaction is exothermic or endothermic. So the effect of, let's take this one here. So you have 2 test tubes here. Maybe let me take it. So here it is. We'll have 2 test tubes. So the first test tube here, number 1, number 2, 1 and 2. So what you will do in those, you will add the pink one. This is pink. This is cobalt 2 nitrate. Cobalt 2 nitrate, that's pink. So you'll add both of those cobalt. So here will be cobalt, salt, and here is cobalt. So both will be looking what? Pink. Both will be looking pink. So the addition maybe 1 ml, 20 drops, 1 ml will be more than enough. You can look it up You can add maybe. It does not really matter. We are not looking at the quantitative, we are looking at the whole thing qualitative, how the color will change. Now, if you look at the reaction, here is pink, here it's hell. So both of them, when you fill them, there will be what? Will be pink. Now this will be our reference. We call it number 1 reference. And then here we'll see the effect of the temperature in both of them. So what you will do here, you will add to the second one HCl, only the second one, HCl. And this HCl, I will add that for you. This is a very highly concentrated HCl. So it has that's highly concentrated HCl, which is about 12 molar. So about 12 molar. That's very concentrated HCl. So I will add this one here because that's very dangerous. So when you add this pink, you add HCl to it, you'll get this one here. The second step, this pink color here. So add, again, the addition is about, I will add enough to see, you see that the difference, you see the blue color. So add HCl. So what will happen here to the second one? The first one is still number 1, pink. Adding HCl, number 2, HCl, it has HCl inside. It will be blue. This is your blue here. That's your blue here when you add HCl. Okay, guys? Then you will have to set up hot plate with the beaker and you start boiling it. So this is blue, that is pink. The first one is pink, second one is blue. Can I take this one out? Take it out? Okay, so let me take out and draw a hot plate. So the next step is to heat this one here with the hot plate. So here it is. So here it is the hot plate. And if you, I will help you to turn this hot plate on. This is your beaker. The beakers are inside at the end of the lab. That's the beaker here, half of it. Just tap H2O, tapper. Okay, so then you'll put your 2 test tubes. So let me just change the color here. One is the pink one, so it has a pink solution of cobalt, and the second one is blue. Okay, this is 2, and this is 1. You start heating it for at least 10-15 minutes to see if it's really any change happened. Correct? So what will happen here, I want to see where's the heat. Is the heat is here or the heat is here? Here at the left, this is endo. The reaction will be said to be endothermic. If the heat at the right side will be exothermic. Now, when you heat those blue solution and the pink color, it turns out to be, there will be no change. After heating, it is. After heating here, after heating, you will see no change. What does it tell you? After heating, no change. Where's the heat will be? But then you take this test tubes here, another beaker here, and I'll bring you ice cubes. My goodness, today is not a good day with this WebEx. But anyway, so you'll take ice. So we said here you are heating, correct? Both of them here. Okay, one is blue, one is pink, and this is hot plate. And here, this is after heating. You put it in, you cool them down. So here it is. So heating, no change. Heating, no change. No change. So the blue remains blue, and the pink solution remains pink solution. But when you not change in color, but when you put this one here inside ice, the pink, we did not add nothing to the pink, so it remains pink. But now the blue tends to be light pink. So what do you think what's happened? What's happened? If I take the heat from the right side, if the heat is supposed to be here, the right side, delta H heat, if I take it from the right side and I'm cooling what? Removing it. So I should have blue color, but I don't see, I see pink color. So by all means, the heat cannot be at the right side. How about the heat is in the left side? Heat here, delta H, heat, enthalpy. So if the heat in the left side and I am cooling here, only I see the change when I start cooling after heating. When I cool, okay, so the heating had delivered me nothing, not changing color. Those two solutions. But when I start cooling, then the color starts pink, meaning when you start cooling, you take what? The heat out. Cooling means you take the heat out. The shift will be which way? If the heat in the left, and you are cooling, you remove the heat, the shift, this arm will be stretched out, more weight, because you can recognize the heat as a weight. You have three weights here, this, and the heat. You take the heat out by cooling, then the shift will be where? And the color, the blue color returns what? Pink. So this reaction is, the conclusion is, reaction is what? Is yes, is endothermic. And that's our conclusion. Because if it's exothermic and I'm putting the heat in the right and I am cooling, I'm removing the heat, it should remain blue, but it's changing the color from blue to a faint light pink color. Okay, guys? So that means the heat cannot be on the right. This reaction is not by all means exothermic. It's an endothermic, the heat at the left. Okay, guys? So let's finish up the lab, and I will just suspend for you. I will suspend for you the HCl concentrate, the 12 molar. It's very concentrated and it's very dangerous. And I would like to have everyone with goggles, please. Everyone with goggles. We are dealing with a very concentrated acids and bases. So because even 6 molar, that's half of the higher concentration. So I'll stop recording now and let's start the experiment. Thank you very much.